Our next unit will be nuclear chemistry. So, what is nuclear chemistry? Well, if you think about it, it's the study of the nucleus of an atom. And so the discovery of radioactivity came in 1895 with a man named William Röntgen. He discovered X-rays, and X-rays are highly energetic electromagnetic waves with short wavelengths. He was German, and so he was obsessed with X-raying everything, and so here's a picture of his wife's hand. And so the next kind of step on radioactivity's timeline is these people. Henri Becquerel. This woman, you should probably know, Marie Sklodowska-Curie, and her husband, Pierre Curie. So what they discovered, and if you notice that they each won the Nobel Prize in 1903, but Marie Curie also won another Nobel Prize in 1911, and that one was with her daughter. They discovered that uranium, an element uranium, it emits radiation, as well as newly discovered elements polonium and radium. So polonium, named after Poland, where Marie Curie was from. In nuclear chemistry, we talk about something called nucleons. What is a nucleon? Well, if you think about it, break it down, a nucleon is something in the nucleus. And so what are the particles inside the nucleus? They are protons and neutrons. What gives an element an identity? It is the number of protons, also known as atomic number. So, back to our original question, what is nuclear chemistry? It is the study of changes that occurs in the nucleus of an atom. So, up until now, we've never said that you could change the nucleus, meaning the number of protons. You could always change the number of electrons and make it positive or negatively charged. You could change the number of neutrons and make it an isotope. But now, what would happen if you change the number of protons? Well, obviously, you're going to change the element's identity itself. So what does it mean to be radioactive? It doesn't mean that something is going to make you morph into the Hulk or turn green or glow. All it means is that an atom is unstable and its nucleus is going to break down or fall apart. In our terms, we'll call it decay. And this decay process makes something more stable. During this decay process, radioactive particles are given off from the nucleus as well as energy. And this picture gives a really nice interpretation of that. You see we have little gray dots and little pink dots. And notice how there's all these pink dots. Those are going to represent neutrons. And it almost makes it seem like the nucleus is really stuffed and very overwhelmed. And so in order to kind of relieve some of that stress or pressure, not literal pressure, but just overwhelming amount of neutrons, it gives off energy, and notice the swirly little arrow and the pink particle, and we call both of those radiation. So what does it mean to be stable? We've talked a little bit about what it means to be unstable, but what does it mean to be stable? Well, if you're stable, you have pretty much an even ratio of protons to neutrons. So if you were to look at periodic table and look at carbon, carbon has 6 protons and 6 neutrons with its most abundant isotope for carbon-12. So that makes it stable. And stable things do not give off radiation and they don't break down or decay. However, if you were to look at something like uranium, uranium has 92 protons and I believe 118 neutrons. It's a really big difference. So between those two, that is clearly not an even ratio of protons to neutrons. And so because it's so skewed towards the neutrons, the nucleus has to get rid of that and give off those extra particles to become stable, or at least become on the way to be stable. So here's a little bit of review, which of course we're going to need to talk about since we're going to talk about things called radioisotopes. What is an isotope? Remember, isotopes are the same element, so that means the same number of protons, but we have different numbers of neutrons. It's kind of like we have identical twins, but one of them weighs more. So DNA is the same, but weight is more. In isotopes, we have different ratio of protons to neutrons, and because of that, some isotopes are unstable. Like I was alluding to earlier, something called a radioisotope is a radioactive isotope. So these are isotopes with an unstable nucleus. And so again, these things don't want to be unstable, so they would like to become stable, and so they will break down or decay to become stable. And if you take a look on reference table N, we have a whole bunch of selected radioisotopes that we're going to be working with. So a couple examples of carbon. Carbon 12 and 13 are stable, will not decay. Carbon 14, unstable, will decay. So carbon 14 has just enough of that difference between protons and neutrons in order to make it want to break down or decay. So which elements are stable and which are not? If you look at elements 1 through 83 on the periodic table, ending with lead, those each have several isotopes and at least one of them is stable. However, 84, element number 84, atomic number 84 or higher, they only have radioactive isotopes. So all of them are considered unstable. So not just the ones that we are familiar with, like uranium or plutonium, but anyone beyond 84.